Hi everyone, my name is Dharmesh Lachmana. My metric number is 241314197. The title I want to present is Design Improvement and Analysis of Wise Bench Assembly. This is my members, Kawindra Ramasamy and Marcos Dungangdong.
So, here for our introduction, computer aided engineering is an essential part of modern engineering design that allows engineers to evaluate product performance through simulation before manufacturing. Finite element analysis is used to analyze component behavior under different loading conditions, helping to reduce development time, manufacturing costs, and design error. Structural analysis ensures that engineering components can safely withstand applied loads while maintaining the required performance throughout their service life. Topology optimization improves material distribution by removing unnecessary material while preserving critical load-bearing region, resulting in lighter and more efficient design. In this project, a work vice bench was analyzed using static structural analysis to identify the critical component, evaluate design improvement, and apply topology optimization for weight reduction while maintaining acceptable stress, deformation, and factor of safety. So for this, we have three objectives. So first being to conduct a static structural analysis on the chosen product assembly and locate the critical part based on equivalent stress, total deformation, and factor of safety. Second is to assess how well topology optimization performs by decreasing the amount of material used for the chosen part while still maintaining satisfactory structural performance. To analyze the strength of the original and optimize design side by side in terms of equivalent stress, total deformation, factor of safety, and material efficiency. So our methodology is CAD model construction. So we have six component models separately and assembled as step five. Then we have material assignment, generation. So we use 5 millimeter of mesh size. Contact modeling is bonded frictional and surface to surface. Boundary and loading is fixed base support, 500 Newton, and applied on housing link. And lastly, being post processing, equivalent stress, deformation, and uh, factor of safety factor result. Thank you.
CAD model and material. When we do a design, we have parts. These are the parts: base, jaw in, base plate, jaw screw, handle, sliding jaw, screw, and bolt. Material. I have take the aluminum alloy to do the Wise bench. Contact modeling. I have four example. First example, sliding jaw part. Second one is body part. Third one is screw part, and last part is flat base. The fifth picture is original design of the Wise bench. Mesh summary. I have four design: original design, improve one, two, three. We want to do mesh. First of all, we want to set the desired value of element size, and then we set uh, the smaller the element size, the more accurate result we get. uh, when I put in mesh to do wise bench is 5 millimeter. Boundary condition and loading. First one is fixed. Fixed support is applied at the base to restrict all the movement of and rotational motion. Simulates actually mounting condition by respecting a securely fixed connection to the foundation. And then the provides reliable stress and deformation result by accurately reflecting the component's structural response. And lastly, acts as a stable boundary condition for accurate analysis of applied loads and overall performance. Second one is force. Clamping force apply on the movable jaw to simulate the workpiece gripping condition. Load direction and magnitude determined based on the expect operating conditions. Stress and deformation evaluate on the jaws, screw, and main body during clamping. And lastly, ensure structural strength, durability, and safe operation of the bench wise under load. Results review. I have four designs. Original design, improvement 1, 2, and 3. We do the 9 steps, and we get we want to solve. In solve, we get maximum equivalent mises stress, maximum total deformation, and factor of safety (FOS). I get the maximum equivalent in original design 1.3627. Maximum total deformation is 0.00159293. This is maximum. And 1, 2, 3 also we get. The one is 2.312. The deformation total deformation is 0.000728685. And we get 2 is 6.2567. Uh, for maximum total deformation is 0.000729191. And then we get lastly we get improvement 3 is 6.6298. It is 0.000711986. And then you can see the FOS. I get all as 15. When do the original design, I get the value, the 1.3627. When you improve the original design, you can get higher the value. You can see the you can see you can see also 2 and improvement 2 and 3. That is the facts. Result static structure. The result static structure is original. First one is original design. You can see in result review the same one. First one. The second one is material type. When we do in structure, we take another material type. I take stainless steel. It get maximum equivalent stress is 2.0978. 0.0002759 is maximum total deformation. And topology optimization analysis is equivalent stress maximum is 2.312. And also maximum total deformation is 0.000072685. And also I take thermal stress analysis, one maximum equivalent stress 108.89. It is get total deformation maximum 0.000027595. This material type topology optimization analysis thermal stress, I take improvement 1 to do the to get the maximum stress, maximum total deformation, and FOS.
Hello everyone, my name is Kavindran Ramasamy and my metric number is 241314071. Today I want to present about topology optimization of our topic, that is voice branch assembly. There are three types of topology optimizations. The first are equivalent one minus stress, and the second are total information, and the third are safety vector. We all choose the maximum value of the three types of topology optimizations for the result and calculations. Hello everyone, and this is our thermal conditions. There are three images of voice bench assembly. The first are equivalent one measure stress, and the second are total information, and third are safety vector of the project. And this is our project different material. And these are three types of image that voice bench assembly. The first are equivalent one measure stress, and the second are total information, and the third are safety vector. Now I want to present the discussions of voice bench assembly of our project. The first are all designs achieve a factor of safety FOS of 15 indicating safe operation. The second are improvement one provided the best balance of low stress and reduced deformation. Structural steel show the lowest deformation, improving overall stiffness. Topology optimization reduce material while maintaining structural performance. And the last are thermal loading produce the highest stress but remain within the safe limit. And lastly, this is our project conclusions, that are the static structural analysis successfully evaluated the bench voice performance. All model remained structurally safe with FOS with 15. Improvement 1 was selected as the optimal design for the further development. Structural steel provided the highest stiffness with the lowest deformation. The optimized bench voice achieved better strength, stiffness, and material efficiency while maintaining safety. That's all from me. Thank you.